Hello everyone, this is a demo for a tool called T3i, which is a tool to automatically test Java classes. So I'm going to show you a number of cool features of this tool. So I have configured the screen here to consist of Eclipse. So here you see at the left here Eclipse, and this is another Eclipse window, and here you see just a plain console. So I'm going to later on start T3i here in this console, and we are going to use it to test this class here, is a class called student, which represent students, and it is a class that keeps track the courses that a student is currently doing and also the courses that the student has passed. Here in the left tab you can see the general structure of this class. You can see here the fields of the class, and you can see here the constructor, and here you can see a bunch of 10 methods that belong to this class student. So let's now start Groovy in this console, because T3i runs in Groovy. And let's now load the prelude of the demo. So this prelude will load T3i into the session here, and importantly it also creates an instance of the backend engine and name it T3. So this backend engine is basically the one that doing the actual work of generating test sequences, and we use a random testing engine, and the reason for doing that is because it's usually pretty fast. So now we can start generating test suite. So let's say we want to have a test suite called S1. We are going to use this backend engine which has been named T3, and then we are going to call a function called ADT, which basically does the work of generating test suite. So you can see that it responds in just a few seconds, and it generates 352, as you can see here, 352 test sequences of average length of 10. So now what's cool with T3i is that not only that you can generate test suites, but you can also query informations on these test suites and also do manipulation on these test suites. So let's, for example, do the following query, which is just asking for general information about the suite. So as you can see here, it says, well, the suite consists of 352 test sequences, and then here it also gives a general coverage information. So for example, it managed to cover the only constructor of the class. It managed to cover 9 out of 10 methods in the class. It managed to cover 87 out of 110 pair of methods that we have in the class student here. Now let's see an example of a more detailed query. So let's see if this test suite, which we have named S1, managed to call a method called addResult, which is one of the methods of the class student. So I will actually ask the query here to count the number of sequences in S2 that visit addResult. So then actually S1, because S2 is not known, S1, and then it says here there are 329 sequences that visit the method here. So this method, in other words, this method is quite well tested. So let's try another query, add course, which is used to add a new course to the list of courses that a student is currently doing. So now, unfortunately, the answer is 0. So it means there is no sequence that cover the method. In other words, the method is unfortunately left untested, which is not very good. So let's now go back to the class student here. So let's take a closer look at it. So this is the method add course that we are talking about here in this query. It expects a string called course code, which is well, just a code of a course. But here in the first line of the method, it first actually checks whether this string here is a valid code of a course. Now the definition of valid here is not shown in the screen here, but it's not a simple definition. So it has a problem with generating valid course code. Now what we can do is we can now try to help T3i by customizing its generator, and I can show you how. It's actually quite intuitive. So let's switch to the screen here. Okay. So this piece of code here. So you can see here is a line of code that specifies a custom value generator for a parameter called course code. So it says here for that parameter just generate one of these strings that you see here. So like info emp, info fp, and info sp, and so on. Now these are actually instances of valid course code. And actually the custom generator here specifies, well, custom generator, custom sub generator if you like, for other parameters as well. So for example, for year it says use one of these integers, and for parameter called result it says that use one of these integers here. And this 3 sub generators is packed into one composition. So then we have here one, well, composite generator, and it's bound to the name mygen. And here you see another line. Let's basically create an instance of the backend engine, and it's called T3b, and to this instance we pass the generator, the custom generator, the generator that we just defined here. So now we can use this custom generator. I have already loaded the definition into the session from the prelude, so we can use it. So let's say that we want to generate a new test suite called S2, and we are going to use the new instance of the backend, the T3b, so the one that uses a custom value generator. So yeah, and now it generates, well, a suite consisting of 400 test sequences of average length of 11. So now if we do the same query, so whether the new test suite S2 ever call the method add course, and then it says that, well, actually there are 229 test sequences in the suite here that actually visit the method. So this is much better than 0, right? Okay. So now the next thing that I will show you is a bit more powerful query. It's called state query. So whereas here you can query about visit to a certain method, and we can also query about visit to certain states. So let me copy this piece of text into the console. So what it says here is that we want to query the test suite S2 using this visit predicate. And this visit predicate here means that, well, I want to see whether this test suite here ever generate a student whose number of current courses, so the courses that he is currently doing is bigger than 0. So actually I'm not just want to know whether this situation is covered or not, actually want to count here the number of test sequences that ever visit such a state. So if we do that, then it says, well, there are actually 229 test sequences in the test suite S2 that satisfies the property, which is good, which means the state is quite well covered. So let's try a second example here. So it's also another state query. It's a query on S2 using this visit predicate. It says here I want to count here how many sequences ever visit a student, ever generate a student whose number of past courses is bigger than 0. So if you do that, then it says there are 4 test sequences. So apparently this is a more difficult state to generate. Yeah, but at least we managed to collect some sequences that are witness of this state. In the next example, I will show you that we can also apply transformation on a test suite. So let me copy this expression here. So what does it say? It says transform this test suite S2, the S2 that we defined before. So this function transform basically apply the function that we gave here on every test sequence in S2. And then the last expression here, it says count. And so it will count the number of test sequences in S2 that can be transformed by this function here. So what does this function here do? So this function swap here will look for the first occurrence of this pair here. So a call to the method addResult followed by a call to the method addFancier. So both are of course methods of the class student, and it will basically just swap the pair around. So then you have a sequence at first call addFancier and then call addResult. Right, so if we do that, and then it says it managed to transform 32.5 sequences from the test suite S2. So next what we can do is that we can also enrich the original S2 with the transformed S2 and the transformed test sequences. So sorry, actually want to do. So let's copy this. So it says here the new S2 is the old S2 plus the result of this transformation here. So now we have the new S2. So next I will show you an example of a more advanced query. So this one here will query a Howard triple. So let's first define the Howard triple. So this expression over here. So what does it say here? Is a Howard triple of this method addCourse. So this method addCourse here, which is a method of the class student here. So a Howard triple is basically just specification in the form of precondition and postcondition. So the precondition here says that the first argument of addCourse has to be a valid string. If you recall, the method addCourse, so this is addCourse, so it takes course code as its only argument, and then as you can see in the code here, it requires the course code to be a valid one. So this is what we express in the precondition. It has to be a valid string, and then this part is a postcondition that says that the course that we just added, it has to be, now after doing the addCourse, and it will be added indeed in the list of courses that this student is currently doing, which is tested with this predicate is doing. We can verify the specification by querying it. So what we are saying here is query this Howard triple that we just defined on the suite S2 and decide whether it's actually a valid specification on the test suite. So let's do that, and then it says it's true, so it's a valid specification. fortunately. All right, so now in addition to just being able to verify whether it's valid, we can actually query a bit more. Now, if we have a sequence that actually does not satisfy the precondition of, well, this was our Hoare triple. So if you have a precondition that does not satisfy the precondition, then, well, the entire Hoare triple actually becomes valid, but it's valid in well, in a trivial way. It does not give us any information. It's simply because the execution does not fit into the precondition. So let's try to query how many sequences actually fit into the precondition. Yeah, so let's do that here. So we query on the test suite S2, and what do we query? We query whether, well, it says count here, count how many sequences in S2 that satisfy this predicate here, where eventually it says here the antecedent of your Hoare triple H hold. So the antecedent of Hoare triple is basically just the precondition of the Hoare triple. So if we do that, and then it says 408. Yeah, so it means that there are plenty of witnesses of the Hoare triple here. So it's quite well tested. Now what we also can do is that we can collect these sequences here. The other sequences are actually irrelevant with respect to this Hoare triple here, so well, we don't actually need them for the purpose of verifying the triple. So to filter that, we are going to do almost the same thing. So this is the same query as we do before, except that now rather than counting, we will do collect. So we will collect all those sequences and then we put them in new test suite is, let's call it S3. Right? So there you go. So now we have S3. We can ask in general information about this S3. So let's take a look. So it says there are 48 sequences here, right? Okay, now the good thing is that it managed to cover actually all the methods in the test class. So let's now save the test suite, because it's, well, it looks like a good test suite, at least for testing, well, the method at course. So let's save it. Let's give it a name, suite underscore at course. There you go. Yeah. Now once you save the course, then you can basically just close the console and then reload the test suite any other time and then replay the execution. Now what you also can do is that we can actually redo the testing from JUnit. So I have prepared such a class. So it's a class called test student. So here you see 3 test functions. They're all doing replay of some saved test suite file. This is the one that we just saved. It's called suite underscore at course, as you can see here. And so this is the file that we just saved. So what we can do is that we load it from this JUnit test class and then we replay it. If no violation is found, well, the method will return it true. So we do assert true, and otherwise then it will assert false, that you will detect violation. Now what we can do here is that we can execute this test here in the usual way as we always do in this case in Eclipse. So let's try to do that. So then, well, here you see the JUnit console as everything is green, so it means that, well, the test passed. Which of course not surprising, because when we generated the suite here, we didn't spot any violation either. So when you replay it, of course, then it will be green. Might also be interesting to look at the delivered coverage. So let's take a look at that. So how many coverage do we get on the student? Well, it says 80%. Let's take a look here. So the good thing is at least the method at course here is now fully covered, right? Because well, the idea here was that we want to have well, a test suite at least especially for this method app course. So it's not, it looks pretty green, it's still yellow here, but this is yellow because well, it's the one that well actually throw the exception here is the course, and because it's the suite contain of sequences, and every sequence is a sequence of calls to the methods of the target class. So along the way it will of course also test various other methods in the class student. So it's not surprisingly you see that not only we get coverage on the method and course, we also get coverage on other methods as well. So we have a lot of green areas, which mean those are the line of codes that have been covered by the test suite. But unfortunately we also see some red areas. So these are areas that are still untested. So we will go back to these later. First I want to show you something else. So let's go to that first. Now a OR triple is, at least in T3i, is a predicate that is evaluated on test sequences. So it's a sequence predicate. And there is another formalism that is more expressive in describing sequence predicate, and it's called LTL, linear temporal logic. So you can also write LTL formulas in T3i. So let me give you an example. So this formula over here, so let's call it LT1. It's a formula that says that this specified predicate here, so this predicate here is a predicate that always hold well along any sequence in a given test suite. So what does this predicate here says? It says that well, the object under test, so basically the instance of student that is keep being tested in a given sequence. And so for that student, so that target student, it should be the case that his number of current courses, so the courses that he is currently doing at any time, should always be less or equal to 3. So students are allowed to do 1 course, 2 courses, 3 courses, but they're not allowed to do more than 3 courses. So let's let's enter this specification, call it LT1, and then we can query that on, for example, our test suite S2. And the way to do that, the syntax is well, pretty much the same as what we saw before. So we query on S2 using this formula LT1 that we defined before, and then we want to know whether the formula is valid, right? So there it goes. Well, fortunately it says it's valid. Well, fine. Well, it's maybe fine. What we also know is that testing is inherently incomplete. So maybe you are a bit suspicious, but this actually is the case. Now what we also can do is, we are suspicious, is we can generate more test suites, and then we can check the formula on those test suites. We also have this function, it's called iterate find. So let me copy it. So what it does is the following. So it will iterate a test suite generator. So in this case, this is a test suite generator. So remember, if this is an instance of T3, in this case is well, this is called T3c. Remember that we can generate a test suite by calling the function ADT. So this lambda expression here is a suite generator. So what we can do is that we can iterate this generator, so every time generating a fresh suite, until we find a suite that satisfies the predicate here. And so what is this predicate here? Is a predicate that, well, that is true when this LT, this formula LT1, so when the LT1 defined before here is not valid. And so in other words, if we manage to find a counterexample of the LTL specification that we saw before, then we stop, and well, this function iterate find will return that suite containing the counterexample. I will not let this iteration to run forever, so I put another an upper bound here, as an upper bound of 10 in the number of iterations that we are going to do. So let's give it a try. So now it will generate test suite. So this is the first one. Well, it doesn't find a counterexample, so now it's trying to do another one, and then it seems to me that in the second iteration it managed to find a counterexample. So we can print this counterexample. So let's try. So I'm going to do the query on S4. This is the new test suite that we generate. So using the iterate find, then we just call the result as S4, as in the expression here. So the result is called S4, and then I'm going to query LT1, so the same formula on this S4, and then I want to print an instance as a sequence that does not violate this LT1, so print a counterexample of that. And let's see, so here you have a counterexample, so it will print basically a sequence step by step. So this is, for example, step number 9, and in step number 9 you can already see here, well, here you have a list of the courses that the student is currently doing, and well, as you can see here, he is doing 4 courses, 1, 2, 3, 4, which is not allowed. So there you have your violation. All right. So well, then you have your violation. So it means that, well, there is something that is not right in the class student here. All right, so now suppose that we fix the this class student, and then we can well, we can test it again. We can rerun the same test suite here and see if we still find a counterexample. However, in this demo, I'm not going to do that. I'm not going to do the fixing here. So let's just move on to the next demo. So now let's go back to the class student. So remember that when we run the previous test suite that we saved, it was a test suite called well, anyways, as a test suite intended to test the method add course. And remember that this part of the code is actually still left uncovered. Well, I can run it again for you if you want to. So let's just rerun it again. Yeah, so as you can see here, this part of the code is, well, is still uncovered. There are more areas that is left uncovered, but let's for now just focus on this part here. So a part of the method get passed here. So what does this method does is to return the list of courses that the student has passed for this given year here, which can be his first year, second year, third year, and so on. Yeah. So the fact that this red here means that for whatever year that well, that the suite passed here, the student actually has no course passed in that year. And so, well, basically the test suite invoke the method, but it keep invoking it at the wrong time, right? So now if we go back and look at our generator, so let's take a look here. So let's turn this off. So look here, what did we do in this test generator? What did we pass for the parameter year? We pass either integer 1 or integer 2. So we only ask well, in this particular case, well, give me the list of courses that you pass in the first year or in the second year. All right. So it means that let's just focus on one of the two here. Let's say first year, the chance of you generating this is 50%. So let's just focus on that. Let's do this query. So let's check whether, so let's hold on. I'm going to write another LTL formula. Let's call it LT2. And it's going to be true on any sequence where this predicate here eventually hold. And this predicate here says that well, the student under test will have will pass. Sorry, the student under test. Sorry, that the number of courses that the student under test has passed in the first year should be bigger than 0. Yeah, so he has passed something in the first year. So that's what the formula wants to know. So the next thing is we are going to query that on our test suite S2. And so I'm going to query that with L2. And then I'm going to do a second query right after that. So basically it's a conjunction of the two queries. So basically what we do here is count the number of test sequences in S2 that satisfies this eventually formula here, so this formula L2, and moreover also visit the method getPassed. And so this is the method that we are interested in. Of course, if you never call getPassed, then you cannot cover that either. So let's count that. Unfortunately 0. So it's not so surprising that we fail to cover this area, because on all the sequences that actually call the method here, then the number of courses that the student passed in, well, let's go back here, in the first year is, well, it's always 0. And we can also query it again for the second year, but it's going to be the same. Yeah. Okay. So what I'm going to do now is I'm going to generate a new suite. Let's call it S5, like this. And I'm going to generate it like this. I'm going to use, well, a different instance of T3 called T3c. It's just a variation of T3, well, the previous one, T3b, with a slightly different value generator. It's mostly the same, just, well, a little difference. Now after generating this, I'm going to apply filtering. And so what I do here, I'm going to query with exactly this predicate here. So give me all the sequences that call getPassed and also satisfies the formula L21, L22, and then collect those sequences. Now only give me those sequences, and then call the resulting test suite S5. So if you do that, then it may appear here that I get 435 test sequences, but that's the information that I get from the generator, from the T3c generator. That's not really, it not well, unfortunately give me information about the resulting of the filter, but we can ask that. So if we ask general information about the suite S5. Okay, so this time I managed to get at least one such a sequence. So obviously a pretty difficult test sequence to get. So what we can do next is that we can add more. So we can do something like this. Construct a new S5, which is consisting of the old one plus, well, doing a similar query and filtering, right? So see if we can in this way get more test sequences. So now if we do this, let's see how many we have. Now we have 2. Well, nice. So let's try to do it a few more times. Let's, hold on. There. One more. Okay, so then let's ask for the information. So now I have 4 test sequences. Yeah, let's see, that's it's not terribly a lot, but hopefully this will do. Alright, so what we do now is that when we are going to save this test suite S5, like this. So now we have saved it, right? So let's now take a look at well, how much coverage do we get now? Do we manage to cover the well, let's see, the area here. Yeah. So here is the same test class again, the JUnit test class. So before we just replay this test suite for add course. So let's now also replay the second test suite that we just saved here. Is called suite get passed. So it's this test suite here. So let's now run both of them. See what it turns. So now, as you can see here, we have 2 test functions, test 2 and test 3. Both are green. So let's now see what kind of coverage we get. So now it says it's a bit higher coverage. So here you see that this part of the code here is at least covered. Yeah. All right, so that was the demo of T3i. Thank you. I hope you enjoyed.